All right, Math 3. So this is our first video for online learning. So we are going to start with adding, subtracting, and multiplying polynomials. This video should only be 10 to 15 minutes long, going over some problems in random order, and then you will need to finish the rest and turn it in to get your attendance being present for the day. So we will start with number 1. So we'll go in order to begin with, starting with number 1 and number 2. Hopefully starting with something pretty simple for us. So we're going to start with adding polynomials. So I know you guys hear maybe this a lot when you add polynomials and you see something like this. You're told to just drop parentheses and rewrite it maybe. So I hear that a lot in other classes, which I'm 100% fine with. Don't think that I'm judging the other classes in any way. One thing that I just want to kind of note is that technically what's happening, the reason why we're dropping the parentheses, is we are distributing a positive 1 on the outside. So I just wanted to note that, and there's a big reason coming up for number 2 why I note this. Not that you have to write that. Please don't write that if you don't want to. But I just wanted to kind of note that that's what's happening. And then after you drop the parentheses, now we are just going to combine like terms. So I'm going to start with my x cubes in gold here, x cubes, and get negative. And I'm going to put negative 1x cubed. That is not necessary by any means. You can go ahead and put negative x cubed. I'm just showing you that this was a positive 1x cubed, and we are subtracting 2 from that, getting us negative 1x cubed. And then now combining our x's, so our negative 3x plus 5x is going to be positive 2x or plus 2x. So there is our new binomial. And now we're going to go ahead and move to number 2. And this is why I do the whole distributing 1 on the outside. Just because I want students to always remember to distribute this negative 1. Right? So I want students to remember to distribute this negative 1. Because what happens is when some students distribute this negative 1, they do this. Please do not do that. Right? You have to distribute the negative 1 to both terms. So please do not forget to distribute that negative 1 to the second term, which should give you negative 1 times positive 7, which is negative 7. And again, just like you would probably for the first polynomial or binomial, you would just drop those parentheses. Again, I'm not upset about you saying something like that. I just want us to know why it's done, because I want you guys to know that no matter how you do something or the method of which you choose, that it is actually a mathematical method, something that is logically makes sense, and you're not just like taking things out or erasing things or making them, disappear or something like that. So I just want us to always kind of think logically and mathematically. And now again, we are just going to combine like terms. I could combine the same colors as I did over here if you would like that. Combining your k cubed and your negative 6k cubed, giving you negative 5k cubed. And then combining your 4 and your negative 7, giving you negative 3. Please notice I am starting with the highest exponent, in this case being k cubed. So now we'll just keep moving along, going on to number 3. And again, the only reason why I want to do number 3 is because I just want to get a little bit of repetition here, seeing the same thing over and over again, right? Getting more and more practice. So again, we're going to do the same thing. We're going to take this and distribute it. Again, it is a negative, so it's a negative 1. So again, I'm going to write that first with negative 2b cubed minus 8b to the 4th minus 6b squared. And then again, just dropping the parentheses, right, or distributing that positive 1 and getting 8b squared minus b to the 4th. And now I'm going to do the same thing. Now, it might seem kind of boring, but I like to repeat myself. I'm doing the same thing over and over. Math rules don't change, right? So I'm going to go ahead and start with your b to the 4th power and get negative 9b to the 4th power. And then I'm going to go ahead and do b to the cube, or b cubed, which there's only one of them, so that's pretty easy. Just minus 2b cubed. And then we have b squared, which is 8b squared and negative 6b squared, leaving us with positive b squared. Now I want you to notice right now I'm about to skip number 4, right? So leaving that for practice for you. Hopefully it's something fairly simple, something you can get through. And then I'm going to go ahead and do number 5 really quick. Oh, I'm sorry, I'm going to skip 4, 5, and 6. So that's, again, kind of all the same things. And I'm actually going to do number 8 for you guys. Kind of a more difficult one, but maybe something that we can kind of go over. So again, skipping 4, 5, 6, and 7, allowing you to do the practice of those. Moving on to number 8. Again, just seeing the different polynomials being added and subtracted here shouldn't scare you. So think of it, again, the same way. You're dropping these parentheses, so you get 7k to the 4th. I'm going to zoom in just a little bit. Plus 1 minus 5k. And then I'm just going to do different colors just for the sake of separating the different polynomials that are being added, subtracted. So then we are adding 4k minus 6. And now this is where the fun begins, right? Distributing this -1 to all of these terms, leaving us 3k to the 4th, my apologies, minus 7k plus 1. And now again, I would even just pause for a minute, just make sure that you distribute those negatives correctly, or that -1 correctly. And now we do what we always did, right? We combine like terms, starting with k to the 4th. So I have a k to the 4th here, k to the 4th here, leaving us 4k to the 4th. I'm going to go ahead and try to use a different color. Now I'm going to look for a k to the 3rd, don't see one. I'm going to look for a k squared, I don't see one. So now I'm just going to go to k. So there are 3 terms here. So we have -5k plus 4k minus 7k. So again, I'm just going to add these all together. So I have -5k plus 4k gives me -k. And then -k minus 7k gives me -8k. And then finally, I'm going to go ahead and do dark green for this. I'm going to circle all the constants. And that should leave us with -4. Again, I'm going over these hopefully kind of quick, or maybe if I'm going slow, that's good, because then you're probably on the right track here. But I'm going through kind of a little quick because this is a little bit of a review from last year. Feel free to always pause the video, look at something. If I go too quick, circle, then just moved on. I do that because I want you to be able to pause videos, go back, look, get that extra help that you need. So now we're going to move to the product of different polynomials, starting with number 9. So again, I just wanted to review distribution. Hopefully this wasn't the most difficult one. We're distributing this 8. 8 times 8 is 64. We get 64n plus 64. Not the most creative one, always using 8 there, but kind of just gives you an idea of how to distribute. So hopefully when you see number 10, which we are not going to do, distribution with an exponent, or I'm sorry, with a variable on the outside, hopefully that won't scare you. If that is scaring you, just wait until we do number 12, and maybe that'll give you a little hint on how to do number 10. So we're going to move to number 12 right now. And some people call this FOIL, some people call it other things. If you want to do the box method, I'm okay with that. I really just do double distribution. I don't know if that's a scientific method or by any means, but all it is distribution twice. So I'll first distribute my x times my 5x and my 3 and get 5x squared plus 3x. Like I said, when I'm distributing that variable on the outside, notice how my x to the first power right here and 5x to the first power, that became x squared, right? 1 plus 1 is 2, right? So that kind of gives you an idea there. And then when I say double distribution, all I'm doing is I'm distributing this -7 now. And I get -35x minus 21. And now I just combine like terms just like we did before. The only things that need to be combined are these 2 middle terms. And now I'm going to keep the outside terms the same color. So we have 5x squared. I'm going to go my light green, get -32x. Positive 3 minus 35 is -32. And then we have minus 21. Again, that's kind of just the idea of what we're going to be doing here. So notice we have a couple other ones, and I'm going to kind of just start us off with these next ones, giving you guys a little bit more output opportunity to finish it yourselves. So the first thing I want to do is do number 13. And again, I'm just going to kind of open it up for us. I'm not going to finish it. So here we have to distribute. We're not doing anything crazy, not doing anything different. And then we are going to do our second distribution here. So I'll kind of just open this up, right? So 6n times 6n squared, which is going to be 36n cubed. 6n times negative 2n is negative 12n squared. And 6n times positive 2 is negative 12n. And this is why I say keep track of the colors here, because notice I did all the top distribution in red and now all the bottom distribution in blue. So hopefully you're kind of staying with me a little bit here. And now we just combine like terms and complete it. So again, I'm not going to finish that. So you guys can go ahead and finish that and then also get more practice on number 14. And that's just kind of hoping that no matter how large your polynomial is, no matter how many terms it is, you're still doing the same methods, right? Nothing's changing. I don't want you guys to be afraid of things or exploring new ideas. Number 15, I do want to just kind of start this. I'm not going to do it by any means because the only thing I want to discourage you from doing is this. Do not do this. Please do not do that. And then I know some of you are thinking, oh, well, you missed the n squared. No, I didn't miss the n squared. I missed a whole lot more than that. Please do not do this. This would be one of the most irritating things if someone did that. That is not how you solve this. When something is squared like this, and I'll do it on the outside really quick. So if we have 3 squared, right, we get 3 times 3. So if you have something like this where this 5 plus 4n squared, you get 5 plus 4n times 5 plus 4n. So that is the end of the video. Again, please feel free to stop, pause the video, try it on your own. I also want to zoom out a little bit to kind of show you, like, look how much I did in class and look how much you need to do to complete, right? So there's still a couple open. I did maybe half of it. Now the rest is for you to try. And please do not forget to turn this in for your attendance. So go ahead and submit it to Canvas and then turn it in. And then that will be your present for Monday. Like you are present. Not a gift for you, but you are present. All right, thank you, and I will see you Tuesday.